right, in this question, we're looking at figure 2.1 here that shows a liquid in a cylindrical container. They've labeled the cylindrical container for our benefit, the liquid, in the area that they're calling A down here. And then we've got a height that looks like it's the height of the liquid. The cross-sectional area of the container is A, good. The height of the column of liquid is H, and the density of the liquid is rho. Show that the pressure P due to the liquid on the base of the cylinder is given by pressure equals rho GH. And so that's an equation. You can say, well, I know how I'll show it. Just the way to show that that's true. I'll just go back up a couple pages to my list of formulae, and there it is right there. Rho GH, right? You can see it. Hydrostatic pressure, E equals rho GH. There, I've shown that it's true. So not quite, right? Even though that is an equation that they give you there, they're asking you to sort of derive this, show that the pressure is given by this. That's worth 3 marks there. All right, so let's think our way through this one. All right, we should always start, if we're sort of deriving something for pressure here, let's start with just the general definition of pressure. So we've got pressure in general, force per area. So here in America, we'll typically measure like pressure PSI, pounds of force per square inch of area. The SI unit of pressure is the Pascal. A Pascal of pressure is equal to a Newton of force divided by a square meter of area. So newtons per square meter is a Pascal of pressure, and that is the derived SI unit. So we need to make some substitutions in here. We can kind of think about, well, what would be the force from all of this liquid here? It says, show that the pressure due to the liquid on the base of the cylinder, right? So there's pressure. So all of this liquid has some force, and it's spread out over the area sort of A here. So we kind of see, okay, area A, that's kind of done for us, but we need to now consider sort of this force that's in here. So all of this liquid takes up space. Anything that takes up space has mass. To say it has mass, to say it has a weight equal to mg, right? The force due to gravity. So the weight of all of this liquid is going to be mg. Okay, so sort of like that's the force that we've got. We got a force equal to mg. But the density of the liquid is given, right? We don't sort of know what the mass of the liquid is. We're given the density is rho. So we know like all of the massive particles, m times the gravity field strength. G would give us the force, the weight of this, the force due to gravity. We have to think about density, okay, as being the mass divided by the volume. Density is mass divided by volume. So we can rewrite this to make it in terms of mass. So mass is equal to the density rho times the volume. You multiply density by volume, you get mass. And so if we think about now making some substitutions, we've got the force, which is the weight of all of this liquid, equal to mg. Still over the area A here for pressure. But this mass is really the density times the volume. Okay, so we got the density of this times the volume. So let's change that to density times the volume. That's what mass is. So we still have a G out here, still divided by this area A. The volume of this liquid is the volume of the cylinder with height H. And how do you calculate the volume of a prism? Cylindrical prism, rectangular prism. In general, it's the area of the base times the height. Okay, so the volume is the two-dimensional area times the third dimension. So we're given the area of the base is A, and now we know, the height is H, and so the volume of this, sort of cylinder of liquid, right? It's not the entire cylindrical container, but just the sort of the liquid that takes the shape of that cylindrical container, but only to a height H. So we'll substitute in for volume, the area of the base, which is capital A, times the height. And so that's what the volume is equal to. So now we've got the pressure equal to rho times volume, but volume is area times height times G over the area, because remember that the definition of pressure was force per area. And so that's how you get the areas to cancel. And you've got pressure equal to rho Hg. Rho Hg, that's not rho GH. But the commutative property of multiplication comes back in to help us out. So it doesn't matter what order we multiply those. Pressure equals rho GH. Well done, everybody.